Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on my virtual machine. There we go. So basically what I'm going to do, I'm going to add two more instructions. I'm going to clean up the code base a little bit, and then hopefully we can start working on the assembly for the virtual machine. So let's go into this file here. Oops, that's not right. There we go, this file. So the two other instructions that I want are index swap. You can swap with a certain index in the stack, and then also index dupe, where you can duplicate a certain index in the stack. So I think you can do that with something like indupe. I would call it idupe, but that might be needs to be reserved once we have different data types. So we'll stick with in for now. Yes, okay. So let's see. Right here, change it to indupe. And the same thing right here. Swap. Okay, and then, all right, let's get rid of some of the stuff here. Okay, so we'll push it, push 1 and 4, and then we'll in swap. Actually, let's push a couple more values so that we can test it a little bit. So we'll make it 6 and then 8. And actually, this is going to take an argument as well. So let's do that. And then, all right, and the same thing here. So that's the index that we are going to be swapping. So maybe I'll actually make this I instead of X, because that makes more sense. Yeah. I could change that in the jump as well. Yeah, because I think that makes quite a bit of sense. Hold doesn't take a value, so I'm not sure why I passed that there. Yeah, so that should work now. Okay, so if we go here, swap, so this will basically put whatever index you are looking at with the top element and put the top element in at that index. So if we do swap 0, that would move 1 to where 8 is at and 8 to where 1 is at. So let's try to implement that. So if we go down here, let's see, let's go to where we have swap. And we will actually yank that. So index swap. All right, so how do we want to do this? So we want to pop the top element. And then we're going to need probably another thing for the stack. So we have push and pop. And then we'll also do swap, and this will take just an index. We need the machine as well as an index. And then let's see. So let's make sure the index is not greater than the stack size, and the index is greater than 0. Actually, or to be equals. All right. Then we will print an error index out of it. All right. So then what we want to do is we're not going to change the stack size at all. So we will just do chain stack index. Let's actually get a temp variable. So temporary value equals we'll get the index, sure, and then we'll set. Let's see. So which one do we want to set first? We want to set the index equal to and then stack size. So that should get the top element. And then we want to do machine stack size equal to the temp value. And I think that should be all that we need to do. So now if we call the swap from in here. And we will push the loaded machine instructions IP dot value. So actually, I do need to change the little. So we can use the push function, I think. Whoops. Let's see. So, so we want to. Actually, I think we can just pop the top. So yeah, we will set that equal to pop instead of grabbing this. And then we will just push here. Yeah, then we can just push temp val. And we actually do have to pass the machine here as well. And that should work. So I think we are going to get an error if we do this. Too few arguments. Oh yeah, so I did not actually provide the argument for it. Here it is. Whoops. Alright, yeah, so we need to actually pass the loaded machine. Alright, so that's not handled, so that's the one I was talking about. Stack size undeclared. Oh yeah, so it's actually machine's stack size. So machine stack size. Alright, so that should work. Alright. So I believe I have forgotten something. Let's see. Yes, forgot a comma there. Alright, and let's see if this actually works. Alright, index is out of range. So alright, so let's see what that actually did. So yeah, I think we need to actually subtract to get it to work properly because of the way it handles stuff. But let's see. So we pushed 1, 4, 6, and 8. Let's not print so that we can view the stack a little bit better. So 1, 4, 6, and 8. And then actually I know what the problem was with that. Right here. Just can't be less than 0, but it can be equal to 0. So that was actually the problem. So now this should swap the two elements. So we have 8 on the bottom, 1 on the top. So that seems to be working. So if we do a few more, so we do 10 and 12, then yeah, so we'll swap it and it should put 1 at the top still. Yeah, so that looks like it's working. So now we can handle the same thing for dupe, and it will be quite similar. Yeah, so we just want to duplicate. So we don't want to remove the element from the top. So let's see. Yeah, can do very similar to this. Right here. So then we'll dupe. Actually, I'm gonna want to call it index dupe. Just so that in the future I'm gonna be separating some more stuff out. So that'll probably be better. So yeah, let's find this. We'll change it to index swap. And then we'll make index dupe. Take the machine, and then we also need the index. Okay. And so I think we can check this exact same thing here. So then, so let's see. So we need to just take that value. So we can just push, it should be pretty easy actually. Push machine stack index. And yeah, I think that should be all that we need to do. Yeah, so let me actually change this to 2. And that should work. Alright. Oh yeah, I forgot to change the value here to 2. Alright, build this again. And I forgot to pass the machine to push. There we go. And now it should work. So, yep, now we have 1, so we should be able to change this. So say we want 6, so that'd be index 2. And yeah, 6 is on the top as well as there. So that's gonna be very useful. Maybe not super useful right now, but in the future, once we're actually compiling programming language with variables and all that, then we are going to want that because that is useful for accessing the stack when you have variables that the scope changes and you want to change the value of them. This would be very useful. So that's why I wanted to add those. So now we'll clean this up a little bit. So let's actually start by making a header file. So yeah, we'll make a header file. And then let's actually open that. Okay. So fine, in header, then we will define it, and then we'll end the if. Alright, so what we need in here, we can put all of these in there. I think that should work. So we'll paste those. We'll leave the program in here for now. We can take all this. And we can take this as well. Alright, so let's see. Yeah, so I'm leaving the program there. Let's actually include that now. Include not time. And then we can just add these. So, see, I'm not sure what the best way about going about it is. It'll go at the bottom though. So we'll take that and we'll put a semicolon. Yeah, this one. There's probably a better way to do this with like a multi-cursor or something like that, but I'm not sure. Not sure about that. So almost there. Then we just have the main function. Alright, so now we can go ahead and do this. So we can do search and replace. So let's see, we have 69 to 80. And we will replace that with a semicolon. Alright, and I messed that up. Alright, let's try that again. 79 perhaps. Whoops. Sorry. I'm not very good at this. There we go. Alright, I got it. Yeah. So I think that should be all that we need in there. And that should make some things a bit easier to work with. And we can also then move it into different files. So if we build that and we run it and it's still working. So that is perfect. So now we can actually separate some things out into different functions. So places where we have a lot of repetition, right? Like we have AB equals that, AB equals that. So we could, let's see. Let's see, I'm trying to think. What is a good way to do this? Should I have a separate function for each one? Or should I put these into a function and then... Alright, well these ones are quite a bit different. Let's see, maybe I will move this out of the main function actually. Yeah, so we'll just make like a void run instructions. Yeah, so that'll take a machine. Okay, and that should actually be all the information that we need, I believe. So if we just actually grab all this here, all the way to the end, then we can paste it in here. And some of it did not work. Alright, this is probably because I'm using my mouse. Alright, now it should work. There we go. Alright, so we don't need this actually, because we're going to be passing that. So then we do have to change this to just machine. There's not too many appearances of that though. Actually, there's quite a few. So let me see. How far does this go down? So one, how many lines is this? So I can search and replace it. Let's see. So that is 158. So yeah, we'll do 7 to 250. Oops, 27 to 250. And we will replace loaded machine with machine. There we go. Alright, we just missed the last one. So that should be better now. And then what we can do here is we can do run instruction and pass the loaded machine here. Yeah, and that should be all that we need to do for that. Alright, we do have some problem. Oh, so we need to actually declare these up here in this function. Okay. Loaded machine undeclared. Alright, so there is one where it did not work. That is okay. Alright, perhaps there's a few. Yeah, where there's the arrow after it. That looks good now, okay. Alright, there is still one more. 123. So I went right past that. Where is that? Did I not save it? Okay, I guess I just didn't save it properly. There we go. Okay, so now it doesn't work. Alright. Why is that? Did I delete something that I did not want to delete, perhaps? This should work. Oh, because the stack. Okay, yeah, let's see. Well, this should update from this, right? Well, let's just put it at the end of this function. Alright, now it should work. Oh yeah. Gee, there we go. And it still doesn't work. Okay, so something is very wrong here. See, does it not work at all? So if we do this on each iteration, nothing happens. Okay, so there is an issue. It is calling the function. So I guess we lose information about the machine when we pass it here. So I'm not sure why that would be. Oh, okay. You know what the problem is. Load, read, program from file. And yeah. Alright, so that's the problem. I accidentally moved this. Now it should work. If that is the correct argument. It still does not work. That's not very good. That is not good. If I get rid of this. Oops. Hang. So when we read the program from the file, we have to actually set the machine equal to that. Alright, what if we take it and put it in this function? Alright, that is not declared because it's with the machine. Alright, and if we run this, alright, it does not work. So let's see if we can print the, let's print the machine program size. So that must be set to 0 for some reason. That's size to that's fine. 7. Okay. Alright, let's add this here. Yeah, it still doesn't work. I'm not sure why this isn't working. Um, right, and we do get there. So it is working. Oh, I don't have. All right, now it should work. Yeah, okay, there we go. So the problem was that we weren't loading it. I just forgot to put the print stack back. So I should be able to put that down here now. Whoops, I didn't do that. I'll put it back down here, and it should print it there. Ah, this needs to be loading machine though. That is what it is called. Yes, alright, so that is all working now. So that was the problem. We can not load any of this or any of the debug. And okay, it is working again. So, alright, that was just a stupid mistake. So that can handle all the instructions now, and it's its own separate function, so the name looks a lot nicer. Let's not do this. Okay, yeah, so we don't need those running. Well, actually, that's probably nicer. Just have them running. Yeah, let's actually put all those together. All right, and there we go. So now, I think we can get started on Lexing our assembly. So let's exit out of here, and let's look at what that might look like. So let's make a asmlexer.c. Actually, so I was thinking about it. So for the name, this is the titanium. That's like the name of it. So it could be TASM or just TASM. Because the TASM makes more sense because like periodic table is TI or whatever. But TASM looks a lot nicer, I think. So I'm probably gonna go with that. So let's do test.TASM. So that's what we'll call it. I'll call it that. Yeah. So I think it should look something like this. Pretty basic stuff, right? So you can push 27. You can push 28, and you can also pop. Basically the same as the instructions. It's basically a one-to-one of the instructions. And then you can also swap. So instead of pop, you can swap, and then it would be that, and then you can print. We should probably change the name from print, actually. It should be like what would it be called? I suppose dump is valid. Dump. Or just top. We could or show. I don't know. There's quite a few different names, but you get the idea. So that's what it'll look like. Yeah. So let's try to Lex this. So push pop, swap, do. Let's try to Lex some of those right now. So if we let's touch hasmlexer.c, and then as well as hasmlexer.h. So let's go into here, and we will include that and name, then return 0. Okay, so let's also open the header file. If not defined, lexer h, then define it and end it. Okay, so we'll have the name in here. So we need some tokens or token types. So let's make an enumerator, and we'll call it token types. So we can have a couple different things. So there could be actually it's going to be basically .h. It's going to be basically the same as these. So I think we could actually just use the instruction set for the tokens. Since the assembly is basically just the human readable version of the bytecode. So I'm pretty sure we could use these as the same token types. So yeah, we'll just need to include that in .h. Yeah. Is that going to be a recursive definition? Well, let's try to include include tasmlexer.h here, and then we'll open the build.sh, and we will add that. And so now if we build it, yeah, so let me get rid of that anyway. Alright, yeah, we build it now. I got rid of it, so I don't. Alright, so, oh yeah, so we can't actually have the main in here. So we will change this to Lexer. That's what we'll call it. And yeah, because the main is saved for the team.h file. Alright, and if we run it, and that works. So I think we can use that. So that will be our tokens. So we need to open a file. So let's actually do a file, or not file. It'll be open file. And we'll take a file, or we'll take the file path. And so I actually have, from my other compiler that I built, I can basically use a lot of the similar stuff to what we have here. So if I just copy all this, it's not going to be exactly the same, but can I not copy it across instances? It does not seem to work, so I'll have to do this. Alright, I guess I can't do that at all. Alright, well, so we can, it's not very much. So 0, I can do that. FC file 0 cn, so this will get the length of the file. So length down 5. And then we will go to the beginning. And then current equals that. And there we go. So we have that, and we'll read by one instance for each, for one character. And then we'll close the file. Okay, so actually we didn't open the file. So we do that, let's see, I suppose we must do that in the main.c. Yeah, so this is what we want to do. Alright, so we have the, whoops, yeah, we want, let's see, so we want a file, and we'll fopen file path with right, just standard right. Alright, that should be all that we need for that. Let me actually try to build that. We need to include a couple things. So I know I'm going to need string.h and probably assert.h as well. So yeah, alright, so we don't actually return anything here. So we want to return, and we will actually do current equals open file, and we'll pass, for now, we can just pass the test.tasm file. Alright, unused current. Alright, that's okay. Let's print it then. Alright, so we now need to go in here. Let's see. Into .c, and we can let's just Lexer. I think that should be all that we need to do. So let's try to build it. And it did not print anything. So let's actually check for errors, because I'm not really checking for that. So if not, then error could not open file that. And we will exit 1. Alright, and then let's see. If not current, then error could not get read from 5. Actually, we do want to open it with read, not write. I don't know why I thought that. Alright, now, so it doesn't work. Is that the right 5? Yes. But we don't have anything in here. Alright, so now we try it. Yeah, there we go. So we do get each character. So now we can iterate through each character and then do something different depending on what we get. So yeah, so we get the current here. So then wall current. Let's see. Actually, we should probably return the length from here as well. What if we just pass it as a pointer? And actually, yeah, we will pass that. And then take the length instead of defining it here, and then that should. That's not work. Let's see. They wrapped. I apologize if that is not right. Followed. Thank you very much. I appreciate that. Okay. So oh yeah. So this needs to be a pointer. And it still doesn't work. So oh yeah, because we need to then dereference it when we actually use it. That makes sense. Alright, so now almost there. Yeah, same thing here. Alright, and now it should work. See, wait, what is the non-zero function actually? So I forgot. Yeah, alright, I need to actually do this. The wall current is less than or equal to 1. And we'll just print current. And that should actually that's not right. I need to do that. There we go. Alright, and we have some problem. Yeah. Actually, so then we need current index. And we'll print that. There we go. So yeah, actually this can be current index. Alright, and that should work. And it goes right. Okay. So I forgot to iterate current index. That is quite important. Alright, and there we go. So now it prints everything, each individual character. So what we'll do is we'll check if it is alphanumeric, and then if it is, we will generate the word based on that, and we'll go until there is a space or a new line or whatever. Yeah, so I think we can do that. So I'm pretty sure we have is alpha is the function. So let's do if current index. Actually, we need to do is alpha. Is alpha. I think that is how it works. Then, so let's just make sure that is the right function. All right, we need C type .h. Okay. Okay. Yes. So that seems to be working. And then we can. There's also is. I think it's is numeric. Is numeric. Current. Oops. Current index. Numeric. So let's see. All right. So is numeric is not right. So what is? Let's see. I actually used it in here. Is digit. All right. That is what it is. Is digit. and that should work. Yeah. So yeah. All right. So that's pretty much all we need, I think, right now. Is one of those. So we can just because we're not gonna have like identifiers, I don't think. But we will eventually with the labels. So we will need to handle that. But for now, we can just generate. Let's see, generate keyword. Yeah. So we'll call it a keyword, and we'll pass the current and the current index. So let's make that function then. So we will put it. That can go at the top. So generate. So let's actually return current index. This can be an int, and yeah. So we will take current, which current is a character. This is an int. Okay, and so we're gonna return current index. So let's see. So we need to while current index while is alpha. Is alpha. Right, and so actually we need to keep track of the keyword name. Let's see. We can do something like that. We can do keyword name. Let's see. So we need also keyword length. My screen is yellow now. And then keyword length equals current index. And then we can do current index plus and also keyword plus. So we should be able to do something like that. So actually, I think here we want to return the token. So let's actually define what the token is going to be. So in here, we can create a struct, and this will be a token. So what do we need for the token? We need a token type, which is going to be of one of these. So instruction set. Instruction set type. So that's the type. And then we also need the text within the token. So text. And then we should also probably have a line as well as a character. That'll be for error tracking, because then we can print it out. So let's do else if current index is the new one. So I'm probably gonna clean this up a little bit, but then we can do, let's keep track of the row. So int actually 1. That's what line equals 0, and then int let's see, what did I call it? Character equals 0. Then we can do, if we encounter a new line, then we do line plus. And then otherwise, like, no matter what, we do character plus. So do we want to start line at 1? Probably do. And character at 1 as well. So then at the end, we can also do character plus. So then we'll need to pass those values here. So generate keyword line and character. Or, yeah, so we probably should line and character. So that, I think, is all that we need for the token. So now we can define tokens. So let's see. So let's do token equals that. I'm thinking we should make something. Yeah. Let's see. So now we have the keyword. So let's see. What are we gonna check? We can actually make a void or a token. Generate token. Or create token. Initialize token. Init token. And so that is going to take all the values that we need. So we need the line, we need the character. And then also we need value or text. And then we need a token, which is actually called instruction. What's it called? Instruction set. Type. So then what we can do here is we can create a new token. And we'll set the type equal to type. And we'll set the text equal to text. We'll set the line equal to line, and we'll set the character equal to character. And then we'll just return the token. So I think that should work. So let's do init token. Let's see. So we need to pass a type, so we'll get to that. And then we already have the text, which is just the keyword name. We have the line and we have the character. So actually the character, yeah, it would be the start of the word that we print out for the character, I think. So that is fine. So then here, yeah, so we'll have to just check built-in keywords. So yeah. Let's see. So yeah, we'll do expression set type equals that. And we can just pass type here. So let's do that. So we are going to do instruction set check built-in keywords, and we take we just take the keyword name and keyword length. We'll just take name and length actually. Name and then name. And then we will just do a string comparison. We will need to check if it's null and all that. I'll do that after though. So if, let's see. Actually, I don't think we need that. Yeah, I don't think we need that. So let's try doing something like if string compare name is push equals 0, then return expression. Let's see. So what is, we define it in here. Yeah, instruction push. So I think we should actually do nope first actually. Oops. Yeah. Nope. And then else if name and then push equals 0, then inst push, and then we can copy this. Yeah, make it there. This can be and let's actually, I want to check if this is working. So let's see. So we have push. Yeah, so we'll get rid of that for now because I just want to see if this will work. Alright, let me just run it, and we'll go through the key or the problem. Alright, well actually I know there is one problem. Here we don't actually pass the name. Keyword name. Yeah. Alright. Generate keyword. It reaches the end of function. Yeah, because we actually want to return the token. And let's see. So the current index can just be a pointer. Yeah, and then we'll just pass current index. Okay. Whoops. Alright, let's see. Yeah, it doesn't actually return it. So we will do token equals that, and then return token. Alright. Check built-in keywords. So I didn't return from here. Oh yeah. Otherwise we will return null. So I think we can do that. If not, we can return -1. Current is set but not used. So that is in here. Uh, I'm sorry, I'm not gonna try to pronounce your name because I'm gonna mess it up, but followed. Thank you very much. I appreciate that. Okay. All right. So unknown token. Did I not actually define the token? Did I put it in the wrong place? Right. Did I not save that? Right. Okay. Unknown. All right. So it still doesn't. Did I include it up here? I did not. So that is actually a problem. All right. Now it should work better. All right. So I forgot a semicolon. It would seem. It says on 11. Huh. Perhaps I actually messed up in here. Or in here, I mean. Token. Yes, I did. Did indeed. Alright. So now we have some more problems. Control. Alright, check built-in key. But I am returning no. Okay. Alright, I'm not sure why it says that. But we'll get back to that. Let's see. So it looks like I'm probably missing another semicolon somewhere. But X pointer from an integer without a cast. Alright, let's see. So in init token, keyword name. Alright, yeah, we will pass that. Current is set but not used. So we are using current here. So why would it not be used? Let's see. Uh, hmm. Not sure. Alright, let's see. Alright, and I did actually mess up instruction set. So that is right here. And this needs to be dereferenced. Alright, there's not too much here. Instruction set is unknown. Because we do actually need to include that. No, I should be including it in here, actually. Or in here. We are including it. So I'm not sure why instruction set is unknown. Alright, and so that doesn't work. So let's just return negative. Type instruction set. So did I spell it wrong? Copy that. Set. Yeah, so that is right. I'm not sure why it is undefined. Is it because of this definition? Yeah, well, that actually causes a lot of problems. But that seems to be the problem. So it's like a recursive definition thing. I think I will. This isn't the best, but I think I can just do something like that instead. And then we just call this, oops, token types. We do have to update it with each one. I will figure that out. A better solution for it. But for now, that should work. Let's actually globally replace set with token type. Yeah, call it token type, not types. Okay, now let's see. Alright, invalid initializer. Uh-huh. Name. This needs to be that actually. So hard leakage followed. Thank you. That's a nice name. All right. Yeah. So we have to do that. Token types is not defined. That is in here. I forgot to change that back. All right, and now we just have that problem. So that is in here. I need to save that. And now, shoot. Okay, yeah. So I think I can fix this by just putting this, shoot. I mean, in here. Press that one. So let's actually do type instead of inst. So if we just place here with inst with type, it's here inst with type. There we go. And then we do have to change that in here as well. We don't have too many occurrences of it though. So inst with type. All right. So now let's save that. And then we also need to save this one. All right, and let's see. All right, now if we run that, segmentation fault. Okay, that is progress though, because it does compile. Let's see if we get to the random place. It does not. So it is probably I think that actually. No. Let's see. Let's see what we get to here. We get through one iteration. So mhm. So we should get to here. All right, we get twice. All right, and then up here, let's see. This says, all right, so it is probably seg faulting here. Let's see. So let's get rid of this. Oops, get rid of this one. Could use a debugger for this, but I feel like this would be faster. So we don't ever make it past there. We actually make it here. We do make it there. So we break in here on the first iteration. So I might want to just use something like that. Whoops, whoops, whoops. All right, let's see. Could that be better? So we make it farther. Uh-huh. So do we make it through? We don't make it through the whole thing because it should be more than that. So yeah, all right. So now let's actually current indent. Ooh. Oh yeah, you are right. That is correct. I mean, that is probably what the problem is actually. We'll probably do that somewhere else though. So let's see if we make it through here now. No. But that was a good catch. Let's see. Am I doing that somewhere else? Because it is doing this. All right. Value. Oh yeah. So I think I need to do that, right? Yeah. Okay. There we go. We got it. So yeah, the problem. I think you need to actually do. I forget how it works. There's a different syntax that you have to do. One second. Something like that, maybe. No. So that's not it. Let's see. I forget. Right. Yeah, that's not right. I forget the syntax. Yeah. Well, I can just see the plus equals one. That is fine. But yeah, that was the problem. So, whoops. Oh yeah, I still need to dereference it though. Yes, indeed. So now we make it through. Let's see. let's print. Let's see. So we should encounter a push. So let's print F push. And let's make sure we do encounter that. Alright. So we do not. Alright, let's actually check here. So if type equals -1, then we will, let's see. Then, well, for now we can just assert that actually. Okay. Assert. Yeah. Type does not equal -1. In the future, once we have labels or whatever, then we will need to adjust this. But for now, we can just assert that. Let's see. Custom identifiers are not implemented yet. Yeah. So that should work, I think. So that is not a problem. It's not -1. Oh. Alright, let's see. Alright, so that does not work. Yeah, I did not say that before. Yeah, so let's see. Do they might have to be a positive number. I'm not sure. I forget how enumerators work exactly. Well, it should still work though. Alright, so it is -1. Yeah. So let's see. I think I could actually probably set one equal to that. In here, if we do type none. That might work. So then if we do, I don't know if that's supported, but we can try. Yeah. So then that's a little nicer, maybe. Yeah. So problem is that we're not doing that right. So let's print what the name actually is. Name. Keyword name. Whoops. Alright, and let's see what it is equal to. Push 2. Do I have oh, because we are printing something else. Why does it print 2? So why would it? Oh, because I think we actually need to do. Yeah, we need to actually set the last. Yeah, that's what we need. Keyword name, keyword blank equals. Yeah, we need to set it to that so it knows it's the end of the string, and then otherwise it is just getting random values that we don't want. There we go. So we do actually, let's see, I need to move this because that goes there, and then we can print pop. And we'll also add one for note, or not, or however you want to pronounce it. And now, yes, so we don't need to print the name anymore, because it is working out. Yeah, so we have push and pop, one exact. So if we change it, so we have push, and then not, and then pop, and then push, we should get that. Yeah, alright. That looks pretty good. So that seems to be working. So we should be lexing it now, because I think we generate the token as we need to, and then return the token. So we will need to create probably like a stack of the tokens. Let's see. So let's get all the tokens implemented, and then we'll worry about that. So we can basically just take everything that we have here. All right, we already have those, so let's just yank that. We can put it up here for reference. So let's see. I want to do it in this order because that's the big, you know. Name. So that is the next one. And then we can just link this. And then, yep, alright. So we'll do it a couple of times. Whoops. Okay, so dupe, and then after that we have index dupe, and we have swap, swap and index swap, and then add. And so actually what I want to do here is type none. Yeah. Alright, so let's see if I can do, whoops, do something like that. Yeah. Let's put a space there and then select it. Okay, now I actually have to make it. Alright, yank that. There we go. So now this is a bit faster. Okay, so now we have add, sub, multiply, divide, and mod. And that should be the right order. Multiply, divide, mod. Right. So we have compare equals, compare not equals, greater, and less. So compare equal, compare not equal. And actually I put an extra space here. Alright, and we can copy this again. Do it properly. There we go. And fix it there. Alright. So then we have compare greater. And less. And let's see, what else? So we got all these. Then greater equal and less than equal. Greater equal. Alright. Then we have the jumps, print, and halt. So I will take these and put them down here so they are easier to reference. Right there. That should be good. Alright, just give me 1 second. Okay, I apologize for that. I received a text message, but we are back now. I will probably have to go in a minute, though. But yeah, so compare. All right, so now we have the jump. So I think I have, yeah. So jump. Yeah. Whoops. Meant to do that. I did not mean to do that either. All right, and just a couple more. So we have jump, and then not zero jump. And then, oh shoot, actually zero jump first, and then not zero jump, and then print, which I'm gonna change the value or the name of print, but for now it is print. So I believe that is all of them. Oh, and we need halt. My bad, I forgot about halt. Yeah, I'll just type that really quick. Now we can return the token values. So for this, return type in dupe. I don't have regular dupe. That's kind of important to have. All right. Yeah. Type do. Type in do. Return type swap. Got the semicolon. I can get rid of these print statements for now. And return type in swap. Do type add. Sub. Multiply. Let's see, I'll paste it all in. Okay. Whoops. PP. Alright, that was pretty good. One. Okay. Now we have hold. Print. NZ jump. 0 jump. Regular jump. Compare less than or equal to. Compare greater than or equal to. Compare less. Almost there. Almost there. Compare greater. Not equal. Mod. Oops. Mod. And div. Alright. So we got them all now. So let's actually make sure. Alright, it does compile. So I'm guessing that we typed them right because otherwise it would not. So we should be able to generate all the tokens now. So let's actually make something to print the tokens. Yeah. We'll put it at the top because I think it makes sense to go at the top. Maybe under that. So it can just be a void. Print token. Token type character. No, just need the token. Token. And then let's see. So what we have all of these. So we'll do the switch statement for the types. So that's going to be quite similar to this. Let's actually, we just copy this. Then this case, let's actually switch token.type. And then we will actually do that. Okay. And yeah, I need to figure out the multi-cursor thing because it is not ID. Well, actually, I could just do a search and replace, I think. If I do that, actually, 33 to 55, or maybe 60. And we'll replace type with case type. There we go. Yeah, I have a double case now, but that's okay. Actually, I have a few of them down here. Alright, and then we can also do the same thing for the commas. So, yeah, 32 to 60. Place the comma with a colon. There we go. And then, yeah, break. Break. Yeah. I guess I could have probably done the same thing for that, but so it isn't too bad. Oops. And so we don't need this here actually. Yes. Okay, so then so right now we have this. So let's print that. And then let's see. We might have a none. So we really want to check if we have a none. Because if we do, that means something went wrong. All right. So that's we'll make sure these work right now. So what else do we have with the token? So then we need to just print that text is that, line is that, and character is that. So token dot text, token dot line, and token dot. So we should be able. Right. So I actually did mess up. Oh yeah, I replaced it all the way there. Okay, so we need to actually call this though. So the token is that, and we'll just print the token right here for now. All right, and okay. So we have type push, text is push, line is 1, character is 1. So actually this is not right. Because, yeah. So, yeah. So we do have new lines in there. Mm-hmm. Perhaps we need to check this first. So let me grab that. Alright. Yeah, because they aren't all on line 1. So that is a problem. Yeah, okay. So I think what we actually have to do is index right after that, because there we go. And that actually seems to fix the problem entirely. So character 3. Ooh, yeah. So we also then want to set character equal to 0 each time we counter anything. And yeah, so all these should be on character 1. All right, and the types are correct. Yeah, so that is pretty cool actually. Yeah. So we are Lexing the assembly. And so the parser, initially at least, for the assembly, it's going to be pretty simple. I think because the it's not very complex, because it's a very low level assembly type language. I think we can just use, instead of a tree for the parsing, we can use just a linked list and then just iterate through each one like that. And I think that would work. I have to think about it some more because I'm not going to be able to do that today, but I will be thinking about it because I think we might be able to do that, and that might simplify the parsing of it. So let's actually let us finish this. All right. So type alt, and then we'll just test out every keyword. Here we go. Okay. Almost there. Whoops, I accidentally. All right. So now it should be working. We build that, no problems. So let's just take all of these, and then we will unindex it because that's kind of confusing. And then we will let's just replace all of the type with nothing. Yeah, it's like that. And then we just need to, let's see, I don't know how to unlowercase it actually. So let me get a word. Or uncapitalized. Decapitalized. Yeah. That's probably what do that. I guess I could have just looked it up. But I'm already almost done. So, let's see, what was that one? Okay. Paired greater. Paired less. Paired greater equal. Paired less equal. Jump. Zero jump. Not zero jump. Okay. And oh, let's actually get rid of all of those. And there we go. So now we should get okay. So one of them is wrong. So let's actually it was right after Indu. So oh, it's because I put swamp and not swap. Alright. Now if we run it, there we go. So they are all proper keywords, and it seems to Lex them properly with the correct line numbers. I'm assuming. One, well, yeah. So one, yeah. So that is good. So, but if we do something like that, will it put the right character? It looks like it does actually. Yep. All right. So that is cool. So we have support for that'll be good for air handling. And we are lexing each character. So we do need to handle digits right now. And that's pretty much all that we need at the moment is digits and then the identifiers. Yeah. But that is going to be it for today. So I will actually go ahead and post this. Actually, let me do something first before I do that. There we go. I want to edit the git ignore. So yeah, let me just close that here. All of these. All right. Okay. Git ignore. Okay. Recover. Alright, him, and then we also need Lex. Lex, I guess we have to find it already. So maybe we don't need to do that. Yeah. Alright, that's all good, I think. Alright, so we will commit this. Added Lexer support for built-in keywords. And then we should be able to push that. Okay, and it should be up and running. Okay, yeah. So I will put that in the chat if someone is interested. And then yeah. So yeah, that's gonna be it. I appreciate you watching. See you next time.